All right, we are here. I'm gonna take a minute and rearrange because this wonderful room of mine requires some rearranging in order to do anything. Hot that still is. Ooh, she's still toasty. She toasty. We're gonna give that a minute. Not quite certain how we're gonna do that, but we gonna figure it out. Well, you can almost see my face. Bada boom. Good enough. Good enough. Backlighting? We'll get rid of that. So we did fix the lighting issue because that's a super bright LED 42 inch 42-inch light bar, which is absolutely absurd um, and absurdly bright. So this actually holds the new eyeballs. Now, if you look at the new eyeballs, they've got a cutout inside of them. So the cutout inside of it actually is what I got to paint and sand and smooth and clean, and yeah. So that'll be interesting to see how that all plays out. See if we can't get the rest of this gunk off of here. Love how it prints a little ring right there. You try to get that off, even with a flex plate. Sometimes it just ain't having it. I don't like letting it sit on there for too long. Sit there and fight with it. Might still be too warm. So we'll give that a minute. Kill this. Disconnect the Raspberry Pi. Disconnect the 3D printer. Yeah, this is what I got to go through every single time that I drag out the 3D printer, if I plan on doing anything other than just 3D printing. So I try to get as much printed as humanly possible before I have to rearrange again, because I hate rearranging. Honestly, I do. It's a pain. We got about 15 minutes before ads are going to start again. So hopefully we can get kind of set up here. Very gently. Empty storage bin. Looks like another empty storage bin. Perfect. Everything has a home. And they've got homes away from homes. So makes it a lot of fun. What do we got? Raspberry Pi. Octoprint Pi. It's literally just a dedicated Raspberry Pi just to that. See what's going to be a good camera angle here. Can't get a decent camera angle. Wop up, wop up. I gotta do something about this glare too. That's annoying. You gonna focus? Thank you. I'm gonna relocate this camera so it's actually facing me. Extent. Set all that there. This, whoops, dropped it. Don't lose this one. Alrighty. So, you gonna focus? Maybe? I don't know. Maybe it will, maybe it won't. So we got the new soldering iron, we've got nuts and bolts, we've got, this came in today. This is pretty awesome. A little pen drill. This thing is pretty badass, actually. So I use that to drill out all the holes that I'm going to need. So that's a controller for it. We got to try to get this somewhat set up and organized whereas it's functional, which can be tricky at times. More tricky at other times, I suppose. Don't need the wires. Need the wire strips over there. Wire snips. Oy. I don't even have a clue. They said I needed to print this piece off. And I don't know what the hell it's even for. So it doesn't look like it's for anything useful from what I can tell. But maybe it's to release the eyes. I don't have a clue. So let's see if this actually helps now. Does that help? Kinda. Not really. Hard telling. Alright. Turn the keyboard sideways. So controller, give me my soda. Alrighty, I think we're pretty much there. Let's see what we can't change up here. See if we can change to here. Not terrible. Not great, but not terrible. Just put me down here where I'm not going to be used. Be out of the way. That'll do. That'll do, donkey. That'll do. So in case you're wondering why I'm looking over here, I've actually got the full-size screen over here, and I've got a monitor right in front of me that's actually hooked up to the gaming PC, which is down below. And then I've got the streaming machine over here, which then I also have my normal monitor over here because I normally watch the monitor, got the TV, and everything works out well. So let's see how far off we actually are here, or we can get pretty much all of the desk. That's the majority of where I'd be working. That makes sense. Extra tools, well, not extra, but tools that are going to be required eventually. More tools here. So here's where I left off with the build. So we got all the wires hooked up to the servos. So these servo wires just come attached to the servos. Um, the servo up front controls the up down of the eyeballs. The rear servos, this one and this one here, this is going to control the upper eyelid right here. That'll control the upper eyelid, and then the other one is going to control the lower eyelid on this side, and then the same goes on the other side. And then this servo right here is going to control this bit right here, which if I can get it to unlock, which is the up down for the eyeballs. So you got an up down for the eyeballs here. This servo is going to control the left right of the eyeballs. I am completely way off cam explaining all of this. So this servo right here is going to control this mechanism right here for the left right. This one's going to control the upper eyelid. This one's going to control the lower eyelid. And the same on the other side. And then this one here in the middle back here is going to control the eyeballs looking up and down. So once all that gets bolted up, which I waited very patiently for the big old box of nuts and bolts to come in, which that's a friggin' brick. So once we get all the rest of this all bolted up, well, we're going to start with building this is what we're going to start with. This is actually the controller. The controller is going to have a joystick. Joystick's just going to fit in here. It's going to bolt in. So you'll have a joystick, and that's going to control your eyes up, down, left, right. There's a push button that goes on the front of the mechanism here that controls the blinking of the eyes, so they'll actually blink. And then there is a 10K potentiometer right here, which is just a turn dial. And this is going to control how far open or closed the eyes are initially. From my understandings, I don't know. This is not my build. This is somebody else's build. I'm just building it because it's a good starting point for where I'm going to go with it. And we'll worry about that after we get a working product. So I've got a whole bunch of servos here that I'll have to connect to this. This is a servo driver board. I don't know if you can see it. There you go. That is a servo driver board. You can hook up 12 servos on it, and you can individually control each of those by addressing them on the I2C bar or the I2C bus. Um, simple power supply, which I need to get the wire for that. That walked off. Where the hell did that walk off to? Where did that walk off to? There it is. Ah, the power supply cable. So we have power. I'm gonna have to desolder these wires on the button, resolder in new ones because they end just at that point, and I don't want to have to put a jumper inside of the housing. I'm kind of hoping to have all the wires come out of the back of the housing. I got some heat shrink around here somewhere. I'll heat shrink all the wires together. Try to have them all color coded, and then I'll be able to make my own connector, which was the one box here. That's this box here, which is a DuPont crimping toolkit, and it comes with a boatload of connections that you can make. So I want to make a DuPont connector on the one end, so then it just plugs in from there into all the ports on here, and then I can make that wire as long as I need to extend it as far as need be. So I don't have to be, that far away from the project. So that's the length that I would be able to get to. I'd be able to go from there to here, effectively, which is about a foot, which that ain't no fun. So that's kind of what I'm doing today. But first things first, we got to figure out what nuts and bolts we're going to need to be able to piece all of this together, figure out what wires we're going to need to fish through this, and kind of go from there. So, and like I said, this just showed up. Oh, we're in ads. So we'll give those guys a minute to run through their ads. Super long, super long. $16 is going to be pretty long. Do I have an M3 at 6? M3 at 8. There we go. M3 at 8. That's more like me. Might even go an M3 at 6, honestly. They gave me a bag of, what are there, 1, 2, 3, 4 different Allen wrenches. That ended up in the garbage. Fun fact: if you don't look at the entire bag, you'll end up throwing away tools. Which I did. And somewhere around here I've got a wiring diagram, and somewhere around here I also have a idea as to what we're doing with, do this, let's do, let's see here. There we go. I can see that. You can't see it, but I can see it. Guess that's all that matters, I guess. Does seem a bit glary. Is that from over here? No, it's still this one here. I don't know what the hell I'm going to have to do with that to get rid of the glare. I might have to put a mat down so then it doesn't have all that glare. Something like that. But what do we got? We got 1.5 millimeter secure fit for M2 screws on the yellows. We're not using yellows, we're using reds. 2.5 millimeter, 2.8 millimeter. M3 screws for those. Okay. Loose fit for M3. Okay. Cool. So we're going to want to wire this up before we go too far. We get a green for a ground. It's going to need a positive 5 volt. These are not the right ones. 1, 2, 3, 4, 5. There we go. I'm going to use black for ground. Use red for 5 volts. And I realize you can't see what the hell I'm doing. So on here, it's labeled. It'll focus. Focus. Ground 5 volt, VRX, VRY. Come on, focus. So you got an X, a Y, a switch, which is actually the push down, 5 volt, and a ground. So all I'm doing now is just wiring in the wires. Hopefully, if they want to push on, that'll be great. Why you're not having this? Why you're not happy? Oops. Didn't like being on the right way, apparently. Oh, and then we can go blue for X. We'll go yellow for Y. And then we'll go green for the switch. We're not going to use the switch currently, um, but the switch has been modified in somebody else's code. Wow, you're rude. So rude. Um, but the switch, which is the push down, has been modified in some aftermarket code that somebody had modified from the original, to whereas the switch actually acts as this red button right here, so you don't actually need the red button. If I do end up going that route, that's a whole different story. Right now we're just trying to get things wired up so it functions. Just make it work. That's step one. I might need to go through and Dremel out some of these holes just to get everything where I want it. Um, but a handy feature about every phone on the planet, you can take a picture of what you're working on, so then when you get to the wiring later, you know what the hell you're working on, which is highly recommended. Anytime that you're messing around with a whole lot of wires, just so you know, and you don't lose track and you don't burn out all your electronics, because ask me how I know. Been there, done that. Surprise. Wondering, 'cause that's got a catch lip on it, and that's got a catch lip down in it. Oh, it's because I didn't clean these up. I'll have to clean those up. Set that over there so I'm not. Sorry, ADD. A little bit all over the map. Put a lot of pieces in front of me, and all of a sudden it's like, hey, look, stuff everywhere. Which is fine. Unless, of course, you're trying to be productive, at which point, not so fine. Probably hit that with a little bit of sandpaper as well. Just to make sure that it's good and smooth. Yeah, it doesn't look bad. Oh, we can change this crap. Let's go. What we got? Something else. There we go. That'll work. Listen to that instead. Need a little bit better. All right, let's try this again. No problem with using other people's prints. You never know how it's going to print on your printer. So holes might be slightly off. Things might be slightly different. It varies from printer to printer, which is absolutely incredible because it's the same file, you know. But everybody gets the opportunity to slice it however they see fit. And when you do the slicing is when it changes. So I think he only used 0.2 for a base layer. I think I used 0.4, which will throw things off a little bit, but everything's a little bit different. Did you not? Did not. And all I'm doing right now is I'm just opening up the hole in the plastic through the hole of the circuit board. So very gently and very carefully, kind of side drilling this to open that up a touch, line it up a little bit better. Careful not to hit the circuit board because it is a PCB, so there are circuits there. Try not to blow in your guys' ears. As much as you might like the blowing in your ear ASMR, it's not what we're here for. We're here to build robots. Sorry about your luck. What we're gonna do today, at least. This project has got to come to a close. That ain't gonna let me. All right. And sometimes, if you can't get it, you get the pleasure of tearing it all back apart and trying again, which is fine. a lot of fabrication right there. Is put it together, tear it apart, put it back together, tear it back apart. Then you get to tear it all back apart after you finally get everything test fit into place, so you can paint it. Fortunately, I'm not painting this. Um, that's the nice thing about plastic, though, is it's easy to work with. And another thing that I'll be doing later on is some casting, which I'll actually take a 3D print, something like this, piece it all together, and then actually make a mold of it, and then cast it out of aluminum. That's that's once we get on bonfire season, though, which is coming up pretty quick, to be honest about it. So we might figure out something that we can cast a mold out of, and kind of do something like that, because it's a lot of fun taking something that's plastic and turning it into aluminum. I'd have to get materials and whatnot for that, which not really a big deal. I mean, realistically, it's only a few things. You need some baking soda, aluminum foil, obviously a container to smelt the aluminum in, but it's not terrible. I have most of all that stuff still on hand from a previous project that I've done, so I do need to get a new whoops. I do need to get a new stir stick for the smelting pot, but that ain't no thing. That ain't no thing. But once we get onto that project, that'll be a different set of tools that are going to be required. But right now we're just working with some electronics. See if we can't get this piece together. You not? No, why not? Are you why not? You're probably why not. Oh, that's in on an angle. Let's try this again. This is why people do this off stream, because it's a lot of tedious, you know. What looks like took them 5 minutes did not. Um, as you can see, I've already been doing this for a half an hour, and I've got one screw in. Makes sense, right? And this is somebody else's project that was already refined and ready to rock and ready to roll, print it, and go. So you can imagine what the R&D on this the first time for the guy was, which had to have been kind of tedious, I'm willing to presume. Which is also why I take pictures of all the wiring, because by the time that I get to this point of getting everything bolted on, I've already forgotten what the wires are. Like red and black, I know positive and ground, but the X, the Y, the switch button, I already forgot. Alright. Apparently it's a bit toasty in here today. 78? Good grief, yeah. I have to switch into a t-shirt. It's a little bit chilly out today. A little bit of rain, a little bit of nasty weather. It's just ucky out. So we're gonna get onto a whole lot of that kind of weather coming up, and this is where I spend the most of my winter, right here, sitting at the workbench. Just because it gives me a little bit of a sense of accomplishment when I'm able to accomplish at least something. When it's raining and miserable and cold and shitty out and snowy, there ain't a whole lot of accomplishing anything outside. I didn't even spend a whole lot of time in the garage this summer. So 3 out of the 4 are pretty snug. This one not so much. This one's kind of stripped out a little bit, but that's all right. It doesn't have to be perfect. So that's what we're looking at so far. That camera is way too far away from where I'm at. There we go. So that's what we got so far. The guy put his emblem on there, etched that in, which I thought was a nice touch for him to do. I thought that was cool. I'll have to get a link to the guy that built this originally because it's a really cool project. But so you'll get a joystick there, and that'll go onto here. So it'll be like that. These wires are all come out the back. I do need to adjust those wires right quick. These wires are going to need to be desoldered, which is good because we're at that stage where this one needs to have some wires soldered into it. And I'm not certain which one of these is positive ground and signal. I'm going to have to figure out which ones of those are positive ground and signal right quick. Let's take a look. Fairly certain that the center pin is just the sweeper, and then you're going to have a positive on one end and a negative on the other. I could be wrong though. It could be differently. It could be that 1, 2, and 3. Yeah, I've got 3 different wiring schematics for this. What's the part number on this? What is this? WL E10K. Alright, so on this one we have ads, of course. Why do I have to have ads on everything? I don't care about this. No, I don't. That's a dick move. Wow, really? You're just gonna force an ad on me with who the hell knows what the hell I'm clicking on? Cool. That's a dick move. Maybe it's a digit key to do some bullshit like that. So one's a fixed end, variable end, and a fixed end. So one's going to be power, the other one's going to be ground. What it looks like. Look like this one's going to be a positive wiper and then ground. what that looks like. So we'll see whether or not that one actually works like that. Might not. Hard telling. So I'm willing to bet this end will be the positive, this will be the ground, this will be the negative. I wonder if I've already got one that's wired up, which would be nice. Would be nice if I already had one that was wired up. But it's probably too big as well. I know I've got one that's wired up, but it's probably too big. Actually, realistically, it might be perfect. Because there is a knob that sits on this. This knob here is going to sit on here. Yeah, that knob is going to sit on there. All right. Um, yeah, I'm thinking we're going to need another one because that one doesn't quite look deep enough. I probably got another one of these wired up. Give me a second. Let me go and take a look. See if I got another 10K that's wired up already. I'll bet I do. Bada boom. Believe we are back. So, alrighty. Bada boom. Spare parts. Always spare parts. Flux, that is that. Solder's on the reel. Don't lose your twist ties. They're important. Because nobody wants a tangled mess when they go to use something again. So anytime that you get a new soldering iron or replace the tip on your soldering iron, first thing that you're going to want to do is you're going to want to heat it up to operating temperature. This one, you just plug it in. Bada boom, bada bang. I got one of these. It's kind of nice. It's just copper wire inside there. Keep the tip clean. All this can get relocated because it's going to be right in my way. This is all my other wire. Sit over here. Couple things you want to do. Flux. Very important. Anybody that tells you that flux isn't important doesn't know what the hell they're talking about. Better more than not enough, right? Red. Yeah, this thing is just going to be a complete pile, eh? Might have to get a new one of these because these were nice when I first got them. Now they're kind of jank, but automatic depth strippers, they used to work really well. But apparently after a few thousand uses, they they get a little finicky. Don't need to worry about the other end just yet. So as this is heating up, what we're going to end up doing is we're going to end up taking just ever so slightly. First thing you want to do with the new soldering iron is you're going to want to tin it. And all that means is you wait for it to get hot. You're just going to coat the entire tip with solder. You're going to want to keep it tinned. Every time that you use it, you want to add more solder to the iron itself. And this helps it preserve how long your tip's going to last and how well your tip's going to work. you've probably seen tips that are burnt and brown and ugly and disgusting. It's because they weren't tinned and they weren't kept up. So I normally get quite a bit on there. You see, I got quite a bit on there. It's smoking all over everything. I just put it in here, jab it around a bit. And that just kind of gets all the stuff that you're not going to use off of it. And that looks pretty good. So I could probably use a bit more. And you can see it. It's a different. It'll turn the tip a slightly duller color once you got it tinned proper. So once you got that done, I normally like to let it cool off again, just because it gives me a minute to kind of get my bearings without burning the tip out. Now this isn't an adjustable, so normally if you've got like an adjustable, you can just turn down the temperature when you're not using it. This one I actually have to manually unplug it every time that I'm not using it, which gives me time to go through, figure out my wires, figure out what's going on with what I'm doing exactly at the moment, just to make sure that everything goes pretty smooth. That's just me. That's just me trying to keep myself focused and on track. And this one we can literally just turn it around. Oh, that's beautiful. That's beautiful. And yes, I keep a flux brush inside of a plastic bag because otherwise this thing floating around in all my tool bins will get everything coated in flux, which not what we're going for. But dip it in the flux container and put it where you're gonna want the solder to flow. That's what flux helps. That's what flux is there for. It's to help the solder flow into the joints and do what you need it to do. And if you're soldering without flux, you're just fighting an uphill battle. You're not doing yourself any favors at all. So be pretty generous with it because as soon as the heat hits it, it's gonna kind of it's gonna flow. So it's gonna flow with the solder, and the solder's gonna take it away, and it's gonna go places that you might not want it. Um, but for the most part, it does work, and it works a lot better than not having it. So once I'm back to set up, I'll plug back in, give that a minute to do its thing, which once again gives me a minute to go through and collect my thoughts before I start. Make sure I got everything where I want it. Kind of give it a once over. A good way of testing it is as soon as the solder starts melting, once it melts on your tip, you'll see it smoking. Chances are you're probably hot enough. I'm just going through cleaning up what's already there, making sure everything looks decent. It doesn't look terrible when I'm done. Keep your tip clean. Always keep your tip clean. I'm certain there's a joke in there somewhere, but whatever. Doesn't matter. So that's that one. We'll give that one a second to. So there's how that solder joint just came out. If it would focus on my solder joints, that'd be great. So that's how you get a good solder joint. Good connection. I'm no expert at it, but I do a pretty good job, I would say. And then we'll just let that sit over here and cool off for a bit. Good spot for it. Seeing as we were gonna add some more, I wonder if these are marked. Can't tell if that's marked or not. No, that's just the wire branding on it. So I wanted these ones to be a bit longer so then I could bring it outside of the housing. So all we're going to do is just grab a hold of this. And when you're soldering or when you're desoldering, flux is your friend. Flux is going to make it so the solder flows. So even when desoldering, add flux. Add flux. Even when you're not soldering together, if you're desoldering and taking apart, add flux. It really makes your life easier. I promise. And you don't need a whole lot, just a little bit, a little dab will do you. You know, but if you do have, you know, desoldering braid, it's gonna help it flow right into the braid, and then you're not gonna have a huge mess. You're not gonna sit there and fight with it resoldering itself back together. Seen a lot of people do that in the past, which is kind of entertaining to watch, but it's also painful to watch at the same time because it's like, man, you could save yourself a lot of trouble. Just don't do it that way. And another thing is add more solder. Adding more solder is counterintuitive, but it helps. I've never been real great with desoldering uh, braid, but we'll get there. It just takes me a minute. And she does get hot. Just like that. And then is the soldering portion of this stream. Doesn't look terrible. Doesn't look great, but doesn't look terrible. I might end up actually moving that one just a touch. Go through, clean it up a little bit. There you go. Normally I would hit that with some shrink wrap, just to seal them off from one another. Um, where my shrink wrap walked off to is another story at this moment. But this right here is why you always keep your tie wires. Because now that I'm done with this, I can literally just tie this back off and set it wherever and not have to worry about it falling over, snagging on shit. About out of, about out of solder, which is a good spot to stop. The shrink wrap could have grown legs. That's a good possibility. But this right here, nice and toasty, nice and hot. I don't have my heat gun in here, but normally I'd show you that. Yep, that's still blazing hot, but I'll just set that over here, literally on a shelf somewhere else, and let it cool down. Problem solved. Out of the way. Don't have to worry about it burning the house to the ground. Don't have to worry about nothing stupid. So, extra jumper wires. I always got a bin for, always got a use for stupid shit like that. So yeah, normally I would put some heat tape on that, some shrink tape. Um, but seeing as I don't have any of that right now, look at there, my second favorite tool. This is the lesser version of the shrink tape, but just as effective when applied properly, which can be tricky sometimes. And ta-da! That is the hillbilly shrink tape. You are welcome. Works well. Now, Yeah, this is it, man. This is the excitement of it all. Everybody wonders, how those guys do it. Tediously. That's how they do it. Like, you don't see this stuff from Adam Savage. All the tedious hours that he put into to making one prop for, one scene of a movie, one shot, hundreds of hours just dedicated to one piece of one mechanical part of one movie. You know what I mean? Like it's insane. They do a lot of work, and a lot of it goes unrecognized. And yeah, you see it, and you're like, wow, that's pretty cool. And then you realize once you start tearing into it, just exactly the amount that goes into it. Like it's not like it's just a oh wham bam we're done. No, 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 no. There's far more to it than that. I want to kind of have this wrap through. I got you guys on multiple monitors today. So I'd be looking over here, I'd be looking over there. Quite the setup today. Alright, I'm pretty happy with how that's all sitting. I want to adjust this just a little bit more. That out of the way. Another thing about electrical wires is it's like a river. That's how it was always explained to me. You don't want to have really sharp bends in your wires. You want them to flow. You want it to be real, real nice. You don't want it to be, a 90-degree angle in your wire, um, because it will restrict uh, flow. So these, now it's going to be the fun part. Now I got to be able to bolt all this together while it's sitting like this, and I have no bolts ready. You're like, hey, that should be pretty easy. Yep, uh-huh, it would have been, had I been prepared. I was not. Don't fall apart on me. Probably have to give me another bag for that, but make sure you put away all your dirty tools so then you're not making a mess out of things that don't need to be made a mess of. gonna be there, and that'll be there. That can go back to where I found it, over there. But you always want to stay pretty on top of staying organized when you're working on things. How deep do these need to be? This one needs to be 8 millimeter. Looks like it stops there, so I could probably get away with another. Yeah, we'll use 8 millimeters on these ones. This is actually a really nice kit. Picked that up on Amazon. Just needing bolts to tie everything together, you know, just little M2 bolts, M3 bolts, M4 bolts. Oh, I like it. Sorry, I realized half of this is probably off camera, and I realize it after the fact. Does not feel like it's seating. Feels solid though, so we're gonna roll with it. Which it all has to come back apart anyways. It all gets to come back apart anyways because I didn't fish this through before I bolted it all together. Those aren't gonna fish through that tiny little hole with the nubs on the end of them. All right, do it again. It's all good. This is why we do this. Did I mention nobody really streams this kind of thing? Can it, can it take guess why? Oh, it's definitely fun. I'm having a blast. I hope you guys are enjoying me fumbling around and having fun, because I'm having fun. M4s are going to be too big. Let's not get too far ahead of ourselves. We need to tighten this down a touch. Turn that down a bit. Oh yes. What's going on, skin bag? We're just looking at the error of our ways here. Because if you notice, what I'm noticing, that ain't quite gonna go on there how it sits. So I'm gonna have to tear it all back apart so I can put this on there and then piece it all together. Because this isn't gonna work this direction. It doesn't fit. Shit. Yeah, we don't have to take it all apart. We just gotta take it loose, which is fine. I'm good with this. Alright. Apparently we're gonna have to take this all back apart. It's okay, it's okay. It's just gonna take a minute, that's all. can adjust that in the code. It's all right. The more times you take it apart and put it back together, the easier it becomes to take it apart and put it back together. It's a fun fact. Ask any mechanic, they'll tell you. It's so much more fun when you do it the third time, or the fifth time. In my case, the 12th time. There we go. Well, better. Forget to tighten this down while we're in here. Okay. That back through. Should have double checked to make sure that all my wires are still plugged in, but that's okay. We're going to take a leap of faith on that one. I got faith. They're still plugged in. Are they? Oh, we'll find out soon enough. It might be. It should be. Do it like the guys in the military do. How long did it take to tear it apart and put it back together? Ta-da! 3 hours. 3 hours would be. Well, that's the stream, guys. Thanks for coming out. uh, we finally managed to get the remote piece together, so that's going to be the remote. That's going to control the blinky blinky. That's going to control how far open or closed the eyeballs are going to be. So that's just a nice little rocker right there. It's a good design. I like that. He definitely put in some time with the design of uh, this controller. So I'm really liking it. I think it's pretty sweet. Um, hashtag Rudism. Give him a shout out. If you don't know who Rudism is, you should definitely check him out. Um, let's see if we can't figure out what the hell we got going on with life here. Hmm. So Rudism is a huge inspiration for me. Um, I've always dabbled in electronics, and I've always had a lot of fun with them. Rudism actually takes it to a whole nother level. He'll take an Arduino, something like this, except like a Pro Micro instead of an Uno. This is an Uno. Pro Micro, little itty bitty tiny thing. And he'll actually make his own custom remote controls to play video games with. Okay. The level of creativity that requires is just off the charts. And then the level of what I just went through, I can only imagine what he goes through on every one of his builds. So we'll give him a shout out because he is really inspirational and he is cool as hell. So give him a follow. He literally made a remote control out of a baguette. And for those that don't know what a baguette is, it's basically just a long loaf of bread. Okay? And he was playing, I don't even know what. He was just playing there, a first person shooter of a sort, with a baguette as his remote control. So this right here, this ain't nothing compared to what he does, and huge inspiration. He's a lot of fun. So definitely give him a follow. He's over, yeah, he's over in he claims he's not from Australia. Everybody else begs to differ. Um, but he's over in New Zealand, and he's a really, really cool guy. And he is not Australian. Surprise, he's not. But it is a running joke. So if you ever get the chance to say hi to Rudism, say what's up, Aussie, because it's hilarious. So now this has got to get cleaned up. So what I got here is you can see the divot there, but it's pretty rough, and that's because I had to build with a support in there. So I got to clean that up. Now the guy printed this off too, which is amazing. Um, and I think I got to clean this up just a little bit on the inside, but it's got just very subtle. You can see the very subtle grooves on it, and those actually latch into the inside of the eyeball. And I can't get a good camera angle on them. There's kind of one there, right? Kind of there, right down there at the bottom. You can kind of see that it kind of, not really, not really. Well, either which way, this is supposed to latch into this. So then you can put this end here into a drill, and and that ought to work. So I should be able to put that into my drill and just hit that with a piece of sandpaper and clean that up. I don't know what time it is. 7 o'clock, 6:50. That ain't too bad. How long do we got till ads? I am gonna have to hit the bathroom and whatnot here. We got about a half hour till ads are gonna roll again, so that's good. Um, So that's kind of another thing. I don't know if we're going to get to that today or not. Um, it would be nice to get everything wired up for the controller to the actual device. So, and this is also why I make all my wires at different lengths. That way I know that this red, this black, and this yellow is my potentiometer. These two super long ones, that's my push button. And then these really short ones are the the joystick. So having three different lengths of wires like that really helps keep things situated, keep things organized. That way when you're grabbing a red wire, you're like, wait, what does this go to? Wait, what does this go to? So kind of keeping things organized is importante. So I try to do that as best I can with things. Did I do it the opposite way? Maybe I did it the opposite way. How are these tangled? This one, this one. One is fine. That one is tangled. Don't know what we're listening to, but man, cocaine. Gotta go faster. Let's go. Masked Wolf. Vibin'. Definitely a vibe. Definitely a vibe. A vibe that I'm looking for right now? Not so much, but it's definitely a vibe. So with these have got to get wired into this device. That's got to go away. This is the next step. So let's go to the next step right quick. I believe that's just in downloads because I just downloaded it. No, it's in pictures. I took a screenshot of it. Yes. Move that to where it belongs. All right, so this is going to be 0. Now this has got a brown, a red, and an orange. Red is going to be your power. Brown is going to be your ground, and orange is going to be your signal. So, judging by the way that they've got all this plugged up, this is going to be 0 on this end of the board. Okay. Line those up. Brown, red, and orange, which normally it's black, red, and yellow. Yellow is your signal wire. Red is power, black is ground. Everything changes a little bit, just a little bit. So we got 1, 2. This is the center servo. This is the left front, left rear, right front, right rear. So it'll be 0. This will be 0 here is going to be underneath everything. Go away. Perfect. This is going to be number 1. 2 is going to be the left front servo. 2. This is 3, I believe. Correct. This would be 4. Everyone wanted to give me a little bit of a hard time, but that's alright. Alright, so that's those 5, which then leaves us all these extras, all these extra pins here for adding in even more servos. And we will. Promise. We will. Alrighty. So that's all of that. So that being the case, that one's going to need a little bit of play. It's going to need a little bit of play. Don't quite like how that was wired up. That could have been the opposite way. Maybe. I don't know. We'll see how it plays out. But, much like the other one, this one has got a ground, an OE, SC, SDA, VCC, V+. So, the VCC we're going to want to connect to basically everything that's on the 5-volt rail. Doesn't make a whole lot of sense why I'm pulling power from there and there. I don't like that, but that's alright. It doesn't matter. So, this has got options. It's got a jumper wire here. If you plug it into the outside 2 on this side, it gives you 5 volts. The inside 2 gives you 3.3. You got a bunch of extras in the center here for who knows what. And then the same thing on the other side. So this is a 5-volt rail. 5-volt rail comes over to voltage in, which is supplying power to the microcontroller. Ground is then coming out to a ground wire. Not quite certain what these two are doing, but can minimize the confusion a little bit, I hope. Probably not, but we're gonna try. So he's showing 10K resistor to the push button, the ground of the potentiometer. Got the signal of the potentiometer going into A2, A3, no, A2, A1, and A0. A0, A1 is your analog input for the joystick. I should probably share that on the screen so you can see what the hell I'm looking at. Let's see here. Let's see if I can't add another window capture. All right. So here's what we're looking at right here. And trying to make this so it makes sense and still fits on the screen is going to be a pain. That's the wiring diagram that I'm looking at right now. So, oh, trust me, Magic Smoke is the name of the game. Trust me, it is. And avoiding it, that's the magic. But the best part that gets me is up here on this diagram, now that I just shrinked everything back down. Let me blow it all back up so we can talk about it. You got a 10K resistor right here on the signal line of the push button. And they got that tied into ground. So that's a pull down resistor is what that is. So you got a 10K pull down resistor on the push button. Okay, that makes sense. I got SDA and SCL over here, which is your data and clock pins. So this is using a I2C setup. The power supply needs power coming into it. I'm wondering if I need dedicated power into that. It's also using VCC here. So I guess that's just going to use a VCC as a signal constant. And then it can use the ground. That VCC has got to be for normalizing. Realistically, I think you only need to have ground. I think your grounds just need to be tied together. I don't think you need to have a secondary voltage, but with this board, it might require a secondary voltage. So we'll wire it up like that, which is fine. This is fine. That's kind of what we're wiring up there. Then we can hopefully not have any magic smoke, number one. And number two, be able to control, well, first things first is once I get all this wired up, I can power it on. I need to load the Arduino code as well onto the Arduino. Um, but it should zero out all my potential or all my servos. And once it zeroes out all my servos, I can go through and I can hook up all the servo horns once they're in a zero position. But until they're in a zero position, I can't do anything with them. So they're just hanging out, just floating around like junk. So let's see what we got going on here. And I'm going to look at my version that's over here because it's far larger than that one. I got a CL, a clock, got a positive and a negative. This is a male and a female, so this is the positive negative for that. I have got a green and an orange, black and a gray. I've got power and ground linked up here already, so that's good. All right, let's wire up one thing at a time. We'll go from there. I'm going to need extensions for these. So I'm going to need 1, 2, 3, 4, so I'm going to need longer jumper wires for that. That sucks. Um, the push button and toggle are going to be fine. The push button needs a toggle on one end, 5-volt rail on the other. So there's my 10K resistor for the pull-up, whatever you want to call it. All right, we're going to use purple and blue. And clock, yay, which is data. So purple is going to be the clock pin. Blue is going to be the data pin. And this is where things start getting funky because this doesn't really fit right. And we're going to use clock and data. Clock is going to be top, data is going to be the next. So clock and data. Clock, data. The reference is hooked up to nothing. Ground is hooked up to ground. They're using the other ground, I suppose. That could make more sense. Guess that can make more sense. This is when I really like things to be nice and organized, but they never are. Thank you. Then we're going to need a positive and a negative, which is going to be a black and a red. In this case, it's going to be a gray and a white. And those are going to come over and grab the power and ground of. They need to be longer, honestly. Of course, realistically, I don't need voltage in over here either. Because this is going to be getting supply from. Yeah, this is going to be getting power from the actual. Probably just load that. I should probably just load that now. Now the fun part. What happened to my loading? What happened to my loading USB? There it is. And it's the old school serial. Yeah, that's a fun one. I don't know if I have wire installed either. Do not. Alright, that sucks. Let's see if we can't. Booty, booty, booty. Okay. So all I'm doing right now is messing around with my Arduino environment because I don't have the things that I need installed apparently. So we're just gonna. No, I don't want you to do that. Don't do that. Thank you. So what I need to do is I need to go over here and go to tools. I need to go to libraries. Gonna pull that up somewhere funky. No. No, 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 no. Okay, there it is. Let's install that one. Yeah, I guess we install all of them. Why not? Cool. Let's try this again. Done compiling. Upload. Done uploading. Close. Um, Add more things open. I did. I did. Validate. Upload. Cool. That's what I wanted. All right. Now that we know that that's loaded, my wire's back. Thank you. Now we don't have to worry about having dual power inputs and potentially frying things because I don't like it when I have two power inputs. Um, if I've got power supplied from this power supply, I just want power supplied from this power supply. If I had that wire hooked into the Arduino, so then I had to program it and everything else, that's when you get the magic smoke because you end up overpowering the microcontroller and it can only take 5 volts. And if you end up putting 6 volts, 12 volts, I mean, I think I've gotten away with putting 6 volts to it, but 12 volts definitely a no-no. You will burn it out and you will be sad. And I don't want to be sad today. Today has been a pretty decent day. I don't want to be sad. These are going to go, the references, these are going to be my power and ground. So yeah, a little bit of a detour because I wasn't quite prepared on somebody else's wiring for things. So that's that and that. That's going to take a minute. I'm going to need more jumper wires, but that's not what we're going for right now. Right now, we just want zeros on these. So what else do we got here? We got ground and voltage. So these two are also going to be this can be over there. Bada boom, bada bing. So that's going to be the same voltage on that rail. Now, I don't know if I can get away with. I don't know if I can get away with that. I might be able to, because they are separate. I believe I could probably get away with voltage. I could probably get away with 5 volts over here and 5 volts over here at the same time, and still separating the power source. If not, I might just burn up a controller, but that's all right. How do I want to do that? Let's do it the easy way. Just do it the easy way, because this is right here. Alright, now realistically, if I slap power to this thing, it should zero out all my servos. Why is that spinning continuous? That should not be spinning continuous. Guess we could probably look at the code that I just loaded. Move down to what? Alright, so what are we doing? We're bringing in the wire library, which gives us access to I2C. Adafruit driver library, PWM, PWM driver, ties it to PWM. Servo min is 140, servo max is 520. Pulse length count, maximum pulse length count. Servo number 0. All our variables. And long pin A0. Okay. So we gotta at least wire up. Here's what's on A0. Unless I've got a 360 servo in there. That might be a 360-degree servo. And it might not be liking this. Shouldn't be a 360 servo, though. They all came out of the same batch. We're reading the X value, mapping it, doing a digital read of the switch value. Y value, we're doing another read, mapping it accordingly. Trim value, we're doing all the same. There we go. Now we're setting the X pulse, the Y pulse. The switch is high. It's doing all this. Oh, okay. So it's reading the switch is high right off the rip. Hey, spell them. Yeah, we definitely want to exclude the smoke. There's no doubt about that. It's gonna force me to wire everything in. Um, and if that's the case, I'm gonna take a little bit of a break and hit the bathroom and stretch a little bit. Um, because it's like what's going on here in the code is it's looking for these values. Okay, and this is the main loop. This is what it's going through. But it's looking for these values so it can map it, and then it's coming down here so then it can set it. And what's happening is it's not getting any values up here. And when it doesn't get any values, it's just throwing it into a stupid loop so it doesn't know what to set anything to. So I'm gonna have to go through and wire up the controller to the breadboard and then tie that all into the Arduino. I was hoping I could get away with it, but it's not gonna let me. Um, but I am curious. I am curious. Okay, so it does need external power for all of that. That's good to know. So it does need to have separated power. Yeah, and once you get the separated power, you see this flashes, and you can probably hear it, and it just keeps moving. Now you're not gonna see it on camera because it's ever so slight, but it's moving because it can't find where zero is. We're in ads. That means I'm gonna take a break. We're going to throw up. Do I not have anything? I don't have anything on this scene. What image is this? Not even an image. Let me see if I can't get cancel that. Go to studio mode so I don't screw with anything. We can go up to, I know Game Scheme got it. We can copy this. We can come down to just chatting scene and we can paste. Paste a reference of that. Just chatting. So that's all my junk. Okay. Turn off studio mode because I hate how that looks. Alright. I'm gonna go and hit the bathroom and do a few things. And then I will be right back. All right, and we are now back. Sorry about that. A little bit of an extended break there, hitting the bathroom and whatnot. If you're just joining in, we are in the process of wiring up a nightmare, as it turns out. So that's what we're doing. So we'll get there. So that'll be that. This is the power and ground on this. Where are we at? Yeah, so this code is literally looking for the servo that's moving is the one that's tied to the potentiometer, um, which would be this one here. So that one's moving because it doesn't have a zero because it's not wired in. And it's looking for it. So we're going to close that out because we don't need that. Close that. We don't need that. I do need this. Let's see what the hell is going on here. So I've got a power. And then my signal is also tied into ground, which that ought to be fun. So that'll be fine. So I'm going to have power over here. It's going to be here. Signal is going to be tied into ground. What's going on, Cyan? Sorry if you caught me while I was on break there. Pull down for that. We're going to drop this back a little ways just to give us some room to work. We're going to give that, I need a lot. I need 5 different wires for that. I need 3 more wires for this. Alright, we are going to need 5 wires there, male to males. No, female to male. On those, I need 3 more female to males. Where's my wire bin? Give me a wire bin. What do we got? We got 5, 6, 7, 8. 2, 3, 4, 5, 6, 7. I need 1 more. What do we got here? This is 1, 2, 3, 4, 5, 6. That'll work. What was that? 1, 2, 3, 4, 5, 6. I need 2. Do I have another color? Because that would be cool if I did. A lot cooler if I did. Got black and white. Those are males. Or females, rather. I need male to female, male to female. I don't want to use the short ones. Come on. Gotta have something around here that's useful. No, I don't. Of course I don't. Why would I? Alright, I guess we're just gonna double up on colors. Or we can use... Actually, we can use gray and white. Let's do that. Gray and white will be fine. That ought to be able to wire us all in, and then I'm gonna need one for the push button. All the rest is going to be plugged directly. Those two are going to plug directly in. That'll be plugged directly in. So realistically, I just need one short jumper for that. And it'd be nice if I had a slightly longer jumper for that. So what's that going to be? That's going to be a push button. So we'll use... Do I have any singles? Singles would be right. Green. What color did I have coming off of that? Oh, I just needed a black. It doesn't matter. It can be a green. It doesn't matter. It's just a single jumper. It'll be fine. Oh, and I had a green and an orange. Well, I already got a green and an orange being used. It'll be alright. Alrighty. Now, seeing as we're knee-deep in a project, let's take a look at what I had for wiring. Switch is green, so we're not using that one. So realistically, I just need 4. Ground is black. Red is 5 volt. Blue is X. Yellow is Y. X and Y. X is orange. X is A1. Y is A0. That'll be fine. Dripping on spare parts, because that's what I do around these parts. Alrighty, so this is actually going to be just a male to male, right? Bada boom, bada bang. We'll wire this up. This is going to in 2. Didn't even need a long one for that. That'll be 2. Perfect. That'll be that. Now let's get the rest of these wired in. Not going to work very well. ground. This is for the stepper. Not the stepper, but the potentiometer. Oh, and then I'm gonna need power and ground here, which is the joystick. Wow, really? Okay, that's junk. Guess I could probably just see how that one works. Let's see how that one works, shall we? Alrighty, where was I? Alright, that's that. Let's give me, this was a positive. Didn't hold at all. That'll work. This is the signal wire for the potentiometer. That one needs to plug into A2. Signal wire. Alright, what do we got for this yet? Got blue, green, and yellow. Blue, green, and yellow. Believe blue is useless. No, blue is useful. Green is useless. And blue and yellow. Yellow is Y. Blue is X. Okay, she's not happy. What happened? What happened? What went sideways? That's what went sideways. All right. Brown, so I can. Let's take it steady 5 volts. That's the question. Is what's taking steady 5 volts from this thing? Everything. Everything's taking 5 volts from this thing. Okay, where'd my cable go? So we're gonna do it a little different. Apparently what's happening is it's under voltaging. So the power supply that I have providing power is not providing enough. So let's see if we can't fry out the entire stream all at once, eh? This ought to be a good time. Bada boom. Hello, McFly. Plug it in the right way. She's awake. She is not happy. She is not happy at all. She is not happy at all. Why are you not happy? What the hell is wrong with you? What the hell is wrong with you? Ground is tied into ground. Everything's plugged in, right? It's just not very happy. Green is a switch. Green's not even being used. What in the world is the problem here? We're on 5 volts. We got 5 volts to everything. Is not happy about this. Not happy about something. What are you not happy about? You got a clock, right? Yeah. You got data. Nothing. I got nothing. The world happened here. You're right. Well, that's fun. That's a lot of fun, isn't it? So apparently nothing produced the magic smoke just yet, but it's definitely not having it. Definitely doesn't like it. It's not having it. And that's way too much to be powering from the Arduino itself, which is what he's showing on his diagram here. His diagram's indicating that he's powering everything straight off the Arduino, which Oh, okay. That makes sense. That makes sense. So we're pulling a VCC up here. Uh, yeah, we're pulling a VCC up here. So realistically, I should be able to take this set of wires here. Yeah, see, now all of a sudden it's saying let's play. So I need ground and I need positive here. There she is. Welcome to the party, bitches. So yeah, it was trying to backfeed. I disconnected the ground over here, but I didn't disconnect the power. So it was trying to backfeed and repower something that already had power. It's a good way of, frying everything that you own, but hey, you only live once. It's only money. And this one's not having it now either. Why are you not having it? What's your friggin' problem? What is your problem? Why are you being a pile? So it's got power from there. It's picking up power on ground here, which doesn't make any damn sense. I mean, it makes sense, but it doesn't make a whole hell of a lot of sense. I'm curious as to why. Curious as to why. Why that would be such. So it's got that wired as a pull down. I'm wondering if. Wondering if that's even affecting it. Honestly, that shouldn't be a freaking pull down. If it is a pull down, it should be done in the code, not the wiring. No, it's still not happy about it. Why are you still not happy about this? That's why. Why is that? It should be wired as a pull up, not a pull down. If it's coded as a pull down, that's retarded. Considering Arduinos have got built-in pull-up systems on them. What doesn't make sense is what doesn't make sense is why this is pulling power from here. Doesn't make any sense. Something wrong with the wiring on this. And I don't know if it's on my end or on his end, but that doesn't seem right. Because the Arduino can only put out so much power. But why it's using VCC? Oh, it's using VCC for the I2C bus. Makes sense. But what it doesn't make sense is well, it worked a second ago and then it stopped working, then it worked again. And that's tied into a pull down, but it's also branched into analog too. Or no, that's not analog, that's digital too. Huh. That doesn't make a whole lot of sense. It's tied into ground. And then the 2. Fine. This shouldn't be two separate power supplies though. And it should be two completely different sources. Shouldn't have a problem there. Let's have a problem. That's a problem. That's all on, but this doesn't have any lights on it. Surefire way of burning shit up. Plug shit in while it's on. That says it's got power to it. I turn that on, then all of a sudden it's backfeeding. That does not have enough power to control 5 servos. There's no way in hell. That's everything powered, but now this doesn't power. Is curious. So if that doesn't have power, then servos aren't going to move. Nope, nothing's going to do nothing. It doesn't have no power to it. Ain't got no gas in it. Well, this has got me baffled. I'm wondering if I fried something out. Or if I just got a junk friggin' so I got nothing here. Which of course that would make plenty of sense to have nothing. Reference is SDL purple. Purple is the SCL. SCL is yellow. Yep. Blue. Yep. Go back through and triple check my wiring. That's got a jumper over to the ground. That's got a 10K pull down. Wire it in right. Power signal ground, correct. All the way through. Power and ground is wired on this. It's got solid connections. This is only looking for a 5-volt in, which makes no sense as to why it needs a 5-volt in when it already has 5 volts coming to it. Makes 0 sense to me right now. Why does it not make any sense to me right now? staring at it for too long, that's why. Because it's got shit connections somewhere, which wouldn't surprise me. Still doesn't make any sense. That shouldn't have any power to it, as the power supply is not on. And then when the power supply comes on, it wants to shit itself. Like it's being backfed. There is no power being fed over to that. The 5-volt out is here, and that's feeding into here, which would then be back feeding into this rail, not this rail. Which that shouldn't be on unless, of course, this had power to it. No? Okay, who the hell? I'm gonna have to check the spec sheets and see what the hell this is all about, because this is more than likely the fucking problem right here. Everything else is wired accordingly. I hate it when things are wired accordingly and they don't work properly. That's annoying. Yeah, that's not even... Yeah, that's just being a pain at this point. That's not doing anything worthwhile. Hopefully stream didn't die. Didn't burn up my computer or anything. Shouldn't have, but... Voltage. I'm just going out to ground. Ground. Yep, something has clearly gone sideways. Not a fan. Not a fan of why things have gone sideways. That shouldn't be supplying power to this. And it seems as though it's supplying power to that. Shouldn't be, though. Wait a minute. There's power here. Really don't like wiring everything into the Arduino like that. That's a lot for the Arduino to be taken in. But that micro board, that breakout board might need everything to be on the same everything, which would suck. Which everything is pretty much on the Same thing, so I don't know what the hell the problem is. Yellow is positive, green is negative, green is negative, orange is positive, positive, negative. Yellow is signal. Kind of loose, but that shouldn't matter. Shouldn't matter. Y and X are still there. Problem is not that. It's not the problem. What gets me about that is he's got a 10K pull down on this, and that just doesn't seem right. This is set up on the ESP32. Let's get the one that's actually alrighty. Alright, so we're going from about 20 to about 45, the potentiometer. So everything's wired here, and everything's working here. So the remote is working. It's giving me all the outputs. So all the wiring from all of this plugged into here is fine. This, on the other hand, is giving me a problem, which doesn't surprise me any. See what happens. Okay. No new line. No line ending. New line. Clear. I give this power, and it does that. So what the hell is that about? Okay. Open pot goes to -8. 18, 25, 25, 19, 19. It jumps around pretty heavy right here. Here's the next section that it turned on. Huh. But I am reading 0 over here. And all these zeros that I'm reading right here. Oh. You can't see what I'm looking at. Who are you? Oh, you're banned. That's who you are. Goodbye. So yeah, so here's what we're looking at in the debugger. Where it's turned to auto scroll. So when I move the potentiometer to the bottom left, you can see the Y goes to 0. You know, that's the bottom. Bottom left is X and Y go straight to 0, which they should. Um, the open pot is the controller mechanism on the bottom potentiometer, which it goes from about 20 to about 50. But this over here is just reading a steady 0. Just a steady 0 on the push button. I wonder if my push button isn't just complete junk. Because that should be sending some kind of information. And it's not. So I'm wondering if I burnt out my number 2 pin. Or if I've just got a bad connection. The connections on that. I might have burnt out my digital 2 pin. Might have burnt that out, or this button is just jank. And if this button's jank, then it's going to cause a problem. So let's do another test. See if I can't wire in just a regular old standard button. Just get a standard button. Yeah, okay. Blind everybody. Namely me. So button state, digital RIN, button pin. Button pin is an input. What if I made this a pull-up? And then just flip the button state. It's not finding that. There we go. Button pin is 2, A2. A1, A2. Pulse length in seconds. Not precise. Verbose pulse. Double pulse. Double pulse length. Pulse. Switch bell. Digital read 2. I don't know why switch is being read there though. That seems like a dumb spot to have a switch bell read. Shouldn't even be inside of the loop. That should be up here. Should be outside of the X val or the Y value, but this is inside of the X value. Why is this inside of the X value? Shouldn't be in here. It's doing the switch, looking for it down here anyway, so it doesn't even matter. It's a bit weird. Well, we know that the controller is wired up. I might have to get a different driver board. It might be the driver board. It might be that my Arduino digital pin 2 is burnt out. Um, which I don't think it is, but it could be, but I doubt it. Could be the power supply. Might be jank. I might have backfed that and fried it. Doesn't smell burnt. Um, Steady there. 5.1 coming out of that. Red. 5.1 coming out of that, so those are fine. Five point one coming out of that side, so yeah, the power supply is fine. Driver board might not be. Doesn't make any sense because that driver board should have power to it right now. And it does. I got 5.1 volts coming into this. The power LED isn't turning on, which is to be expected because it doesn't have signal, I guess. Doesn't have a signal? Well, it's got 5 volts going into it, so that doesn't make a whole hell of a lot of sense. So, I don't know. I might shelve it for the night and try to sleep on it and see what I can't figure out where it went sideways. Because something went sideways. I mean, obviously the diagram matches what we're looking at, but I'm not getting any outputs to the servos. Servos aren't getting any outputs, which doesn't make a damn lick of sense. Unless I burnt this one up. I might have burnt this one up. Doesn't feel swelled or anything, but maybe. Maybe not. Maybe I'm crossing too many wires. Maybe that's what's going on. Not quite certain. This is actually the first time that I've used a breakout board like that. I normally just wire all these in straight down the board. I build out my own drivers for them. So this is the first time I've actually used a driver board like this. And of course, the first time I go to use it, it's never gonna freaking work. So that's that. And we ran this. We verified that it was getting all of the analog inputs. It's getting all the inputs that it needs, all the inputs that it's requesting. It's getting. So I don't know where that one went. When did that one go to? When did this red go to? I don't even remember what this red went to. But regardless, it was getting a signal from it, so it doesn't even matter. Um, yeah, because the push button's up here, so that would be the potentiometer. And it was getting a signal from that because we watched it on the screen, so everything was wired in just fine. Um, I didn't try clicking the button though, but the button's not wired in because here's the button over here. And by button, I mean the joystick clicker. And of course, you can't see anything of what I'm talking about because it's behind everything. That up here, I guess. Whatever. So yeah, so everything on this was working. We got readings from the joystick. We got readings from the potentiometer. We did not get a reading from the push button, which might be the problem in and of itself. It might be the push button that's causing an issue. Um, but he's got it shown as being a pull up, or a pull down rather. Got it being displayed as a pull down in the diagram there. So right here in the diagram, he's got it displayed as a pull down on the signal line. So he's using the signal line to digital pin 2. That's how I've got it wired in. I've got a 10K pull down there. It does not like the fact that I have a 10K pull down right here for whatever reason. And then it's tied in, everything's tied into the same ground because everything's grounded out to the to the breadboard, and then the breadboard is grounded to the Arduino. At which point, my head hurts, and I'm tired of thinking about it. I got quite a bit accomplished today. Got quite a bit accomplished today, so I'm happy with the progress regardless of the outcome. Um, we got the controller built and half-ass wired in. We got code installed. We got everything wired up. Um, Not quite certain what I'm going to do about this at this point because I am getting a little bit of noise, but it's not enough to be concerned with. Um, and the only other thing I can think is this board here is just complete trash. Terminal block is reverse polarity. Terminal block is reverse polarity. What? Oh, reverse polarity protected. Side breakout DINs are not. Okay, so this is protected by reverse polarity. This isn't, which makes sense, I guess. But all the same, what the fuck? So, yeah, I don't really know. Not 100% certain. Maybe I'll screw around with it off stream. Some other time. Maybe tomorrow I'll mess around with that or something. I don't really know. Let's go say hi to the beards. Just because. Just because they're on. Yeah, we'll go raid these guys. Alrighty, y'all. Thanks for coming out. Thanks for hanging out. I don't know who all's here, but thanks for stopping by. Thanks for the subs. Thanks for hanging out. So we'll talk to you guys in a bit. I don't know when, but hopefully soon. See ya.